Imagine a cosmos bursting with potential for life, but here's the shocking twist: the most abundant stars in our universe might be robbing their planets of the very moons that could make them habitable. That's the eye-opening discovery from a new study diving into the tidal forces tearing apart our assumptions about exomoons. As we hunt for signs of life beyond Earth, this revelation could reshape how we view the galaxy's liveliest spots. But let's break it down step by step, because understanding this isn't just for astronomers, it's for anyone fascinated by the possibility of worlds beyond our own. You've probably heard of exoplanets, those distant worlds orbiting other stars. Among them, Earth-like planets nestled in the habitable zone, the sweet spot where temperatures allow liquid water to exist, are prime targets for astrobiologists searching for extraterrestrial life. Recently, scientists have turned their telescopes and models toward these planets, especially those orbiting M-dwarf stars, to look for moons. M-dwarfs are the most common type of star in the Milky Way, smaller and cooler than our Sun, and they make up a huge portion of our galaxy's stellar population. Think of them as the everyday heroes of the cosmos, but with a twist that might make their planetary systems less hospitable than we hoped. In this intriguing research, experts use advanced computer simulations, specifically, the N-body simulator called Rebound and its extension Rebunks, to explore the fate of large moons around these Earth-sized planets. These moons, similar in size to our own moon, Luna, are fascinating because they could play a crucial role in a planet's habitability. For instance, our moon helps stabilize Earth's rotation, creating consistent days and seasons that support life. Without it, climate swings might be wild and unpredictable. The simulations factored in complex three-body interactions, where the star, planet, and moon all tug at each other, and the relentless pull of tidal forces, which are like gravitational tides that can slowly strip away a moon's orbit over time. Now, here's where it gets controversial. The results were startling. Large moons orbiting Earth-like planets in the habitable zones of the smallest M-dwarfs, like M4 types, become unstable and are likely destroyed well before 100 million years pass. For slightly larger M-dwarfs, such as M2 types, the moons don't last much longer, failing within about 100 million to 1 billion years. And even for M0 dwarfs, which are a bit bigger but still on the cooler side, these moons typically crumble in far less than a billion years. Compare that to our solar system, where the moon has endured for billions of years, and you start to see the problem. This means that while M-dwarfs are everywhere, accounting for about 70% of all stars, planets in their habitable zones are probably moonless giants, at least in terms of large, stabilizing satellites. The implications are profound and could spark heated debates among scientists and dreamers alike. By extension, this slashes the total number of potential large moons across our galaxy and the entire universe. Since moons might not only stabilize their host planets but also harbor life themselves, think of them as mini-worlds with their own atmospheres or oceans. These findings dim the prospects for exolife around red dwarfs. And this is the part most people miss: it forces us to rethink big questions like the Drake equation, which estimates the number of intelligent civilizations in the cosmos, and the Fermi paradox, that puzzling silence where we wonder why we haven't heard from aliens yet. If fewer moons mean fewer habitable worlds, does that mean the universe is lonelier than we thought? Or perhaps life finds other ways to thrive without lunar helpers? Of course, not everyone agrees. Some researchers might argue that smaller moons or different orbital setups could still exist, or that tidal forces aren't the only factor in habitability. Maybe advanced life forms engineer their own stability, or perhaps M-dwarfs have other perks we haven't discovered. What do you think? Does this study crush our hopes for a moonlit cosmos, or is there a counterpoint we're overlooking? Share your thoughts in the comments. I'd love to hear if you agree, disagree, or have your own wild theories about life among the stars. This groundbreaking work comes from Sean D. Tidal, Billy Quarles, Nevin N. Weinberg, and Manfred Kuntz. and it's been accepted for publication in the Astronomical Journal. The full paper spans 15 pages, complete with 9 figures and 1 table, offering a deep dive into the data. If you're eager to explore more, check out the AR14 preprint at https://oxford.org/apps/2511.03625, submitted on November 5, 2025. Topics like astrobiology and exoplanets are buzzing with such insights, reminding us that the search for life is as thrilling as it is unpredictable.